Okay, so now the exercises for chapter 25, the second set of exercises. We're going to look at brief exercise 25.3 and 25.4 on page 1288, and then exercise 25.7 on page 1289. So first one, brief exercise 25.3. And I'm going to show you how to do this with the tables like the book shows, and I'll also show you how to do it with a net present value function in Excel. So it says the project has an estimated annual cash flows of $70,000 for 4 years and is estimated to cost $190,000. Assume a minimum acceptable rate of return of 10% using Exhibit 5 to determine A, the net present value of the project, and B, the present value index rounded to 2 decimal places. We have a cost of $190,000, we have a $70,000 inflow. We have a 10% minimum rate of return and 4 years. So I need to use the present value of annuity table, and I know that because I have equal cash flows over a given time frame. So my present value index is going to come from, it's at Exhibit 5, but in that case for us that's the annuity table. And my rate is 10% in 4 years. So 10%, we come down to 4 years, so 3.17 is, I said rounded to decimals, so that's my present value index. The net present value using that index, I simply take the 70,000 times the 3.17, and then I need to subtract, although in this case, because I made it a negative number, I'm going to add, but basically I need to find the difference. You find the difference between 70,000 times 3.17 and 190,000. So 31,900 is the net present value. Remember, all this tells me is that this project returns more than 10%, and to be exact, it returns $31,900 more than a 10% rate of return. So to show you this in the net present value function, equals NPV. My rate is 10%. My values got here. And then remember, I need to add on the back side that 190,000. I could have done this one, doesn't really matter. And that number basically is the same. It's just a little, like I said, a little more accurate with the function than it is just using the tables, but either way works. Okay, 25.4. 25.4 says, it's looking for the internal rate of return. This is a project is estimated to cost $463,565, and so again, I've got it as a negative number. And it says the project is estimated to cost annual cash flows of $115,000 for 9 years. Determine the internal rate of return for this project. So to follow the IRR steps that we used before, it says find the present value annuity factor first. Okay, and the present value annuity factor, remember I take the cost divided by the annual cash flows. Now because I have that as negative, it's going to come out as a negative number, but that's okay. You can either switch to positive, or you can just look at it, just assume it's assume it's a positive number, but 4.031. So then I can go over to the tables. Again, we'll look at the annuity factor table, and the term is 9 years. So I'm going to go to 9 years. I'm going to look for whatever's closest to 4.031, and that would be 20%. So the IRR is 20%. Now, if I want to do this with the IRR function, equals IRR, I'll take my values, remember including year 0, and all the rest of my values. I take my guess, which they don't give us their hurdle rate, so we'll just say it's 15%. I don't think it really matters in the function, so it's somewhere in the ballpark. And it's going to return me an IRR of 20%, which we got with both methods. Okay, last one, exercise 25-7 on page 1290. Okay, it says the following data has been accumulated by Greedy's company evaluating their purchase of $150,000 of worth of equipment, having a 4-year useful life, and And that gives us our information, which I've put out here: year 1, 2, 3, 4, net income, and net cash flows for the years. Assuming the desired rate of return is 15%, determine the net present value for the proposal. And it says to use Exhibit 2 in this chapter. And why it says Exhibit 2 is I want you to notice, number one, we're not using net income because we're not doing the accounting rate of return or the average rate of return. We're doing the net present value, which deals with cash flows. Because these are unequal, I can't use the annuity table. So I have to use the regular present value of a single amount table, the single dollar. Okay, so I got 15%. I got year 1, 2, 3, 4. So I got to go find the factors for years 1, 2, 3, and 4 under 15%. So I got 15% here, 1, 2, 3, and 4. I'm just going to reference those so I don't mess up any typos. Make this easier. And then I can take each individual year, the 80,000 times the year 1, 65,000 times year 2, 50,000 times year 3, 40,000 times year 4, and find the total of those. Okay, but then remember, I need to take out the cost of the project to actually find the present value. In this case, the cost of the project was 150,000. So my net present value, whoops, I made it negative, so I gotta add. This would be my net present value for the project. Total present values of all the 4 individually done for the present value of a single dollar amount, subtracting out the present value of the cost of the project. And so this tells me that I'm returning more than 15% by an amount of 24,460. Now, why I have these down here, but the net present value function, if you want to use the function instead, equals NPV rate, 15%. Cash flows right here. And then remember, I need to add back in the cost of the project, and it came out to exactly the same number because I didn't round any of my factors on my table. It will come out minimally different if you use the tables from the book because they are rounded. And I think that is the last lecture for this semester, as I understand it. So that should be it for chapter 25. And yeah, let me know if you have any questions.